Hi, I'm Mr. Huber, and in this video we're going to talk about problem 4b. Well, look, sketch the following function: 1.5 times sine of pi times x plus 2 in brackets plus 3. What is the geometric meaning of f of x is equal to 4? Look, it's not the same thing. This is f of 4. This is f of x is equal to 4. That changes everything. And work it out algebraically. Well, we know it's a sine function. Well, a sine function, the original sine function, looks somewhat like this. We all know that by now. This is 2 pi. This is pi. This would be 3 pi halves. And this would be pi halves. That's one period length of your sine function. Okay? Well, this is just something we have to know before we start something like this. Now look. The vertical translation is 3. So the middle line seems to go through 3. Okay. And then the amplitude is 1.5. So 3 plus 1.5, that's 4.5. So we know that our function is between 4.5 and 1.5. Here we go. Now the horizontal translation is x plus 2, so that means that the horizontal translation is 2 to the left. So that would be here at minus 2. It starts up here at minus 2. And what's the period length? Well, the period length is, as you know, a sine bx minus c plus d. Well, we have to look at b. Well, the period length is related to b. It's 2 pi divided by b. Well, we're very lucky here because period length is 2 pi divided by pi. So this goes, period length is 2. So this will be our period length. So this will be right in the middle. Okay, let's draw one period length here. So here at minus 1.5 and at 0.5, it will have the lowest and highest point. Look, first I'm only drawing one period length, and then we'll probably draw some more period lengths. So this is one period length of this particular sine function. You see that? Okay. Well, clearly we can go on and say, well, there will be another period from 0 to 2 here. Then there will be another period from 2 to 4, from 4 to 6, and so on. And each and every time we'll have our 0 here. Well, not 0, our point of intersection with the horizontal line. And now I'm just sketching it. The max is always in between these 2 points. As I said, it's far from perfect, but it doesn't have to be perfect. It's just something that helps us think. Here we go. And now we've drawn 1, 2, 3, 4, 5 period lengths of this function, and obviously it would go on here and here. Now look, this is the graph. Now, what is the geometric meaning of f of x is equal to 4? Well, f of x is equal to 4. So that means for which x do we have 4 as a y value? Okay, let's see. Well, 4 as a y value is just a horizontal line. So you can clearly see we do have infinitely many x values that satisfy this equation. Here, 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 everywhere. Infinitely many x values that will satisfy this equation. So we need to work out x. So that's 1.5 sine of pi x plus 2 plus 3 is equal to 4. Okay? Because for which x is this equation satisfied? So what are we going to do first? Minus 3. 1.5 sine pi x plus 2 is equal to 1. Then we divide by 1.5. Sine of pi x plus 2 is 1 divided by 1.5. Well, I know many people like to leave it like this. Well, I don't like that because it's 1 divided by 3/2, so it's 2/3. So sine pi x plus 2 is equal to 2/3. Now look, we've solved something like this in problem 3. We had to solve sine is equal to 2/3. Remember? Well, we used the inverse function and we got 0.73 plus k times 2 pi and 2.41 plus k times 2 pi. Wasn't too difficult with k an element of z. Good. Let's look at this. It's very similar. Look, but in here we don't have x, we do have pi times x plus 2, but it doesn't matter for the moment. Look, pi x plus 2 is equal to arc sine of 2/3. Well, arc sine of 2/3, our calculator did say last time that it's 0.73 approximately. Well, let's recheck that. So arc sine, make sure your calculator is set to the radian measure. 2 divided by 3. Well, it's approximately 0.73. And then, look, the second value here for the sine is 2.41. So this is the first value. And the second value is going to be pi x plus 2 is pi minus 0.73. Well, pi x plus 2 is 2.41 approximately. Okay? Same thing as in problem 3. Okay? We looked at the unit circle and we knew that 0.73 is an arc length and 2.41 is another arc length. So we do have that 2.412 here. Well, we haven't finished yet, but still we have to add our k times 2 pi. K times 2 pi. We've done the same thing here. K times 2 pi. Look, this is a crucial moment. Now you'll see something. Let's divide by pi, both divided by pi. So we're going to get x plus 2, 0.73 divided by pi, plus k times 2 pi divided by pi. And here, x plus 2, 2.41 divided by pi, plus k times 2 pi divided by pi. Look, this is like magic now, because this will be x plus 2, 0.73 divided by pi, I'm not working this out for the moment, plus k times 2. See, this is the period length, 2. Down here, same thing, x plus 2 is 2.41 over pi plus k times 2. Again, the period length is appearing. Now you subtract 2 on both sides. So 0.73 divided by pi minus 2. So x is approximately minus 1.77 plus k times 2 pi. We've just subtracted 2 on both sides. And here the same thing, minus 2. So that's, let's just rework this out here again. 2 divided by 3. So that I get this number again in the exact value of this number. So I'm going to subtract it from pi minus that number in order to get the 2.41. Now I'm going to divide this 2.41 divide by pi minus 2. So it's approximately minus 1.23 plus k times 2 pi. Again, for both k times 2, sorry, I'm so sorry, k times 2. Okay, make sure that you get your k times 2. K is an element of z, and k is an element of z here as well. Now, does that make sense? Let's see. Look, minus 1.77. That could be here. Look. It's quite perfect. And the minus 1.23, that's here. So let's highlight these two solutions. Let's say this is my red solution and this is my black solution. So this is black and this is red. Now look, when you add one period length, you jump to this new red solution. Here, here, here. All of these red solutions. When you go from here, let's make a cross. That's probably easier to see. So now you jump to these solutions. Look. So in fact, f of x is equal to 4. When you have to work it out algebraically, you have to solve this equation quite similarly to this one here. But you have to add the k times 2 pi right after you did your arc sine. Look, we've done that. And then when you divide by b pi here, you get your new period length, which is 2. So that's crucial. It is crucial. Once you've done your arc sine, your inverse sine, you need to add k times 2 pi. Then when you divide by b, you'll get your new period length. And now we have all the possible x values. So it could be minus 1.77 plus 2. Well, plus 2, that would be here. It could be minus 1.23 plus 2. That would be here, this red dot. Plus 4 would be here. Plus 6 would be here. So I hope this wasn't too difficult. See you on the next one.